All right, question 3. I'm going to do the right-hand side because I've asked you to do the left-hand side. So 3b, I'd like to remind you that if it's not in factorised form, a normal quadratic looks like that. So if I have x cubed plus 2, that's a normal quadratic that's been moved up to. So this time it's going to look like. It wants to indicate all intercepts, so let's find these out. So y-intercept x equals 0, I should do that below, no, y equals 0 cubed plus 2, so y is 2, so I'm going to label this 2. My x-intercept, y equals 0, 0 equals x cubed plus 2, negative 2 equals x cubed, so x equals the cubed root of negative 2, which is a calculator job, so I'm just going to write cubed root of negative 2. Although I do have my calculator here. So I have to drop it to get the screen to work. So the cubed root of negative 2, which is like negative 1.26 something. Anyway, it's negative, so there, that drawing will do. Okay, for 3D, sorry, I've got y equals x take 1, x plus 2, x take 3, which means on my axes, I know it's going to go through positive 1, negative 2, and positive 3. My y-intercept, x equals 0, y equals 0 take 1, 0 plus 2, 0 take 3, which is positive 6. So I'm just going to pretend this is positive 6. And don't forget, we always kind of start from the bottom unless there's a negative out the front. Oh, no, I could actually test this behaviour as it tends to behaviour as x tends to negative infinity, just to choose a value of it. Let's do x equals negative 3, y equals negative 3 take 1, negative 3 plus 2, negative 3 take 3, which gives us a negative times a negative times a negative, which is negative. Yep, so we do know that we're starting down here. So let's chuck it in. So it goes through all of these points. 3D done. Okay, 3F. Now here they've got y equals 1 take x. 1 plus x, 2 plus x. Okay, so our zeros, well, 1 take x equals 0, so x equals 1. So our zeros are x equals 1 multiplicity 2, no, gosh, it's not x multiplicity 2 because this other one's x equals minus 1 and this one's x equals minus 2. Okay. For the other one, I didn't actually need to write those out. Like the other two questions I didn't need to write them out because we could see it straight away. This one was just that little bit trickier. I should also find out its y-intercept. X equals 0, y equals, well, 1 take 0, 1 plus 0, 2 plus 0. 1 times 1 times 2 is 4. So it's going to cross there. My zeros, 1, minus 1, minus 2. Behaviour as x tends to negative infinity. So let's chuck in x equals negative 3. Hello. Y equals negative, 1 take, negative 3. 1 plus negative 3, 2 plus negative 3. So we've got positive times a negative, so it's negative. So I know that I'm down here. That's right. No, it's a positive times a negative times a negative. That's totally a positive. Sorry about that. So it's up here. Nice. Okay, yoink, 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 and this point was 4. They're much nicer when you draw them nicely. Classify each graph as 1 to 1, many to 1, 1 to many, many to many. Now just a reminder, our horizontal and vertical line test, 1 to 1, passes both, many to 1, fails the horizontal but passes the vertical, 1 to many, passes the horizontal but fails the vertical, and many to many fails both. So 3B is, it passes both, it's 1 to 1. 3D, it doesn't pass the horizontal line test but does pass the vertical, so it's many to 1. And 3F, same deal, many to 1. That's question 3.